Welcome in our lecture Fundamental of Casting and Solidification. Today we are going for lecture 9, bottom gating system. In last lecture we have discussed vertical gating system and we have obtained the formula of pouring time, that is equal to volume of casting divided by the Ag into Vg. Vg was root 2g ht, height of the sprue plus pouring basin. So, in bottom gating, what happens in vertical gating, filling happens at the atmospheric, minimum pressure should be at atmosphere, all places pressure should be atmosphere. In this bottom gating system, we assume that liquid filling, okay, we pour the molten metal here and fill in the mold from the bottom, we fill from layer by layer, okay, from bottom to top, thus this avoids splashing and oxidation associated with the vertical gating system. So, due to bottom filling stack by stack, what is happening, oxidation is reduced, splashing is reduced. So, indirectly what you are happening, you are reducing your kinetic energy. Okay. So what is happening, it will be oxidation and splashing will be less in the bottom gating compared to vertical gating. Okay. So, let us assume this is pouring basin HB, height is HB, this is sprue HS, and that total height can to call as a HT, HT equal to HB plus HS. Okay. We are assuming the point 1, point 2, point 3 at the just boundary or ingot and casting boundary. This is casting, this is point 3, and we are filling the liquid and some height, this is total height of mold is HM. We are taking a height from bottom is H. We are taking 4 point. Okay, this is 4th point from the bottom. Now, we will write our Bernoulli equation at different points and to get the velocity at V3. It is not easy to get velocity at 3 because it is not at a atmospheric pressure directly, okay, as what we have done in vertical gating. So, we can write Bernoulli equation between 1 and 3. Okay, so what is Bernoulli equation saying? The summation of all kind of energy will be constant at point 1 and 3. It will not, it will conserve energy conservation. Okay, so what that P1 by rho g plus V1 square by 2g plus height HT, head is potential head is HT, P3 by rho g plus V3 square by 2g plus 0, isn't it? We are taking datum at 3. Okay, we are taking datum at 3. Okay, so we know P1 will be P ATM at station 1 at point 1. So, P gauge will be 0.1 is maintained at a fixed position. So, V1 will be 0. We are maintaining HB as a constant. So, HB is fixed. So, HB. So, I will write separately this HB constant, HB equal to constant, and so V1 will be also 0. So, we can write down HT equation 1, HT equal to P3 by rho g V3 square by 2g. That is equation number 2. Now, we have to get P3 and V3, so that we have to get P3 value, because we have to calculate the in gate value, the velocity at the in gate, okay, at the entry of the mold. So, we have to get the value of P3 first. So, there is another relation we can obtain between P3 and P4. We apply the Bernoulli equation and we can get the P3. Apply equation between point 3 and 4. So, what is that? One, 2, 3 and 4. So, we can write P3 by rho g P V3 square by 2g plus 0 equal to P4 by rho g V4 square by 2g plus h. So, 3 we are dividing in such a, in 1 and 3 we are talking about just this side, okay, before entering and just after entering case, okay. 3 is a continuous point where we are taking left hand side and right hand side. So, we are discussing about right hand side part, as this equation number 3, assuming that at end of station 3 all kinetic energy is lost after the liquid enters the mold. So, V3 we are saying, assuming that at the entry of the station 3 the all kinetic energy lost after liquid enter the mold. So, what will happen? If kinetic energy V3 become 0 and converted to pressure energy, okay, pressure head energy, okay, V3 is 0. Obviously, we assume P4 equal to P ATM to avoid any air aspiration. So, P should be, P4 should be minimum P atmospheric, should minimum P atmospheric. So, again P4 can be, P gauge will be 0. So, you can P4 can be 0, P4 can be 0. Now, what will happen V4? Since it is moving stake by stake and point 4 has very low velocity. So, V4 is also 0, okay. So, what was the equation 3? P3 by rho g 3 and 4 plus 0 equal to P4 by rho g V4 square by 2g plus h. This is already 0, this is already 0, this is also 0. Okay. So, P3 by rho g equal to H. What is it saying? All after entering the mold, all kinetic energy, that is V3, is converted into pressure head. So, it is going to fill the mold. Okay. So, V4 is also 0, V3 is also 0, P4 is 0 due to atmospheric pressure. We are assuming that it can't go below the atmospheric pressure. So, P4 is P gauge is 0. Okay. So, cancel out we can do, and so we have got equation number 4, and equation number 2 was St equal to P3 by rho g plus V3 square by 2g. Equation number 3 was St equal to P3 by rho g plus V3 square by 2g, and we will keep equation 4 in equation 2. So, what will happen? Ht equal to H plus V3 square by 2g, V3 square by 2g equal to Ht minus Ht minus H. So, what you can write? Vg equal to root under 2g Ht minus H. Equation number 5. Equation 5 gives velocity of a jet discharge as against a static head H, making the effective head as Ht minus H. What is happening? Effective head is Ht minus H, which is continuously changing. Ht minus H continuously changing. What is H? The distance from bottom, the point 4. And what is Hm? Mold height. So, H will be 0 to Hm. H will vary from 0 to H. Okay. And this is total height Ht. Okay. 0.1, 0.2, 0.3, HB, basin HS, sprue. Okay. So, what is happening? Equation 5 suggests that the velocity of this jet discharge against a static head, already head is H, this head is already there, making the effective head is Ht minus H, not in the vertical getting. What was the head? Ht. Root V3 was root under 2g Ht, but in V4, in the bottom getting, it heads is head is Ht minus H, which is continuously changing along the filling. Ht minus H is continuously changing and become maximum at the bottom, minimum at the top of the mold, that is Hm. So, V3 equal to Vg, volume velocity at T of in gate, V3 equal to root under Tg Ht minus H. Okay. Now, which is varying with the time, obviously height. Okay. So, we can say mass balance, we can take, we know the inlet flow rate, and you are want to fill some volume, that is dV equal to Am into dH in dt time in gate fill dV volume. So, dV equal to Am into dH, and that will be equal to Ag flow rate. We know Ag into Vg into dt time. In dt time, how much flow rate is there? So, how much volume is going to fill by gate. In gate you can write. Okay. So, 6th and 7. So, Am dot dH equal to Ag dot Vg dot dt. We can write what is Vg? Ag root 2g ht minus h into dt Am dot dH. Okay. Am dH divided by Ag 2g ht minus which equal to dt. We will integrate at 0 time and Tf filling time, total filling time. Okay. When t equal to 0, h was 0. At t equal to Tf, h will be static head will be hm. End out. So, right hand side will be Tf minus 0 equal to Tf equal to Am by Ag 1 by root 2g 0 to hm dh root under st minus h. We can write that. We have to integrate okay. I will just put the value, and what will happen? We will put first 0 root ht minus root so Tf will be Am by Ag root under 2 by g ht minus hm. This is the expression for the Tf. So, what is the expression? We will write that Tf equal to Am by Ag root under 2 by g root under ht minus root under st minus hm. Now, we will solve a numerical problem. Same numerical problem we have solved for the top gating, vertical gating. Now, we are solving same numerical problem. We are filling from the bottom. What we have done? Just we have shifted our gating system at the bottom pouring system, and you have to calculate same data where volume is fixed. What is the volume? The cross section area will be, this is 50, this is 20 cm, and depth height is 15 cm as we have discussed in previous question top gating system. And here, so what is the answer? So, Tf, what is Am? Am will be 50 into 25 cross section area cm square, Ag 5 cm square, G equal to 981 cm per second square, ht is 15 cm, HM is 15 cm. TF will be, so TF will, we can calculate the formula TF equal to AM by AG root 2 by G HT minus HM. AM is 50 into 25 divided by 5 into 2 divided by 981. You have to careful about G, because all scales are cm. So, G should be also in cm scale, not meter per second square scale. HT is 15 minus 15. So, 0 to 50 43.71 second. So, same casting it has taken around 43.7 second, wherein bottom gate filling time getting 43 point second, vertical getting top getting was 21.86 second. So, what is happening? If you are going to pour at the bottom getting, then its time will be 43 second, and vertical getting it will be 21.86. It's double, more than double, isn't it? 41. So, what is happening? You can take, if you are top getting, your flow is very fast. You are flowing very fast. You are go to, maybe Reynolds number will be very high. Reynolds number will be very high. Reynolds number rho V L by mu, even rho is fixed, L is fixed, mu is fixed, velocity will be high, because time is low. Obviously, you can understand the flow rate is very high in this top getting system. When in bottom getting system, your velocity will be less. So, Reynolds number will be less, okay, lower. In bottom getting, RE higher in top getting, okay. So, what is the understanding? So, in vertical or top getting, velocity is high, so Reynolds number will be higher. So, what will happen? There is chances of turbulence, splashing can happen, it can erode the mold, okay. Whereas bottom getting, your time will be more. So, you have to think which design you have to go, so that you can be in, if bottom getting, solidification may occur. There is some chance, if you superheat not too much, not sufficient, what will happen? Solidification can start before the filling. So, there is a problem with bottom cooling, bottom filling also. So, what happens? You have to optimize your velocity such that your filling time should be optimum. You have to fill your cavity first, then only you can solidify, otherwise you will not get sound casting. Whatever you do, you will not able to fill, so you can't solidify. If you are very fast, that is also problem, very slow, that is also problem. So, both you can see here. Now, there is just some calculation you can change. If bottom getting, if a riser is used, let us assume this is casting and there is some riser, okay, and you want to fill this mold cavity from the bottom getting or even top getting also. Bottom getting, you want to fill, this is a riser, this is casting, okay, this is riser and this is a casting. If riser is used, the pouring time TF should also be included time need to fill up the riser. if you want to calculate filling time, you have to calculate this plus this, even top gating or bottom gating. In both condition, you have to calculate your filling time based on the riser as well as casting. Why? Riser is going to feed your shrinkage, liquid and liquid to solid shrinkage. It should also be filled. If let's assume you are pouring slowly and you are just able to fill here, okay, let's assume you are just able to fill here like bottom gating. What will happen? You are not filling here, okay. So, what will happen? You are going to shrinkage in the casting. You are not able to compensate your liquid to solid shrinkage by without riser, okay. So, what will happen? You will get shrinkage in the casting, that is not going to be used. Customer is not going to take that product. What is happening? You have to design your such a way that if riser is there, so pouring time should also include there, that calculation also. Based on that, you have to calculate your filling time. Normally, open riser I will fill up to level of pouring sprue. Open, there are two kind of riser that will you understand in the riser section. If open riser, open, this is called open riser, open, okay, open riser. Thus, time taken to fill by riser is calculated by AM replaced by AR. Now, just assume this is the cross section area is AM, as we have discussed, TF equal to AM by AG root under 2 by G into HT minus HM. So, AM was there. For the calculation of time filling for riser, AM will be replaced by AR. Obviously, riser has different cross section area. If let us assume AM and AR are same, so nothing going to change, and HM will be replaced by HT. HM will be replaced by HT, as previous question numerical problem also HT and HM was same. Okay. Based on that, you can design your gating design in top and bottom, and you will understand in horizontal gating system in next lecture and air expression in next lecture. Thank you.